Okay, let's dive in. We live in a world that is just drowning in data, right? So the big question is, how do we find the important stuff, the signal, in all of that noise? Today, we're talking about one of the most crucial, maybe even overlooked steps in machine learning, feature selection. It's really the art of figuring out what truly matters.
And this quote just hits the nail on the head. We are collecting data on a scale that's hard to even wrap your mind around. Every single click, every purchase, every little sensor reading, it all becomes a new piece of information, another feature, another column in our spreadsheet. And the result? We've got more dimensions, more things to analyze than ever before.
So, the natural thought is, great, more data is always better, right? I mean, more info should lead to smarter models, shouldn't it? Well, as it turns out, the answer is not so simple. And it leads us straight into a really fascinating problem. And that problem has this wonderfully dramatic name, the curse of dimensionality. It sounds like something out of a fantasy novel, but it's a very real, core challenge that data scientists run into when they have a ton of features or dimensions to work with.
So, what on earth does that actually mean? Well, think about your data points, like houses in a neighborhood. If you only have two dimensions, like a street name and a house number, all the houses are pretty close together. It's easy to see who your neighbors are. But what happens when you add more dimensions, like floor number, apartment letter, zip code, county? Suddenly, that dense neighborhood spreads out into this vast, mostly empty space. The houses become sparse, and it gets way harder to spot any patterns.
And this curse isn't just some abstract idea. It has some very real, very practical consequences. Your machine learning model might get totally confused by all the noise and start to overfit. That means it learns the training data perfectly, but the moment you show it some new data, it just falls apart. And on top of that, all those extra features cost you in memory, in storage, and in pure computational power. It gets expensive.
So how do we fight back against this curse? Well, this is where our hero of the day enters the story, feature selection. This is the process that lets us zero in on the truly valuable information that's hiding inside these massive data sets. To put it simply, feature selection is all about picking the best, most useful columns from your data. So instead of trying to use all 1,000 features you collected, you might find out that actually, only 50 of them are really doing the heavy lifting for your predictions. It's all about quality over quantity.
Now, it's really important not to get feature selection confused with its cousin, feature extraction. With selection, you're picking from what you already have. With extraction, you're actually creating brand new features by smooshing the old ones together. The huge difference here is interpretability. With selection, a feature like age stays age. You know what it is. With extraction, it might become something like principal component C and, well, good luck explaining what that means in the real world.
And the goals here are just so powerful. I mean, think about it. By picking only the most important features, we get to build models that are way simpler and easier to understand. We can actually improve their performance, save a ton of time and money, and dodge that overfitting bullet we talked about. It's a huge win all around. Okay, so to do this right, we need to know what we're looking for. First up, you've got the signal. These are your relevant features, the good stuff. A single really good feature can just cleanly slice your data into different groups. This is the gold you're digging for. Next, you have to deal with redundant features. The best way to think about this is like measuring someone's height in both inches and centimeters. Sure, both are technically correct, but the second measurement adds absolutely no new information. It's just extra fat that we can and should trim away.
And finally, you've got the pure noise. These are the irrelevant features. They have absolutely no connection to what you're trying to predict. They're just static. All they do is muddy the waters and confuse your model. The whole point of feature selection is to learn how to just ignore this noise completely.
All right, so we want to find the signal, trim the fat, and ignore the noise. Sounds great, but how do we actually do it? Well, let's take a look at the three main strategies that data scientists have in their toolkit.
And they are filter methods, wrapper methods, and embedded methods. Each one is a different angle of attack on the same problem, and each one comes with its own set of pros and cons.
Let's break this down. Filter methods are like the sprinters. They're super fast and efficient. They basically rank features using statistical tests before you even start building a model. Wrapper methods, on the other hand, are the perfectionists. They actually use your machine learning model to test out different combinations of features. The results are great, but man, it is incredibly slow and computationally expensive. And then you've got embedded methods, which are kind of the sweet spot. Here, feature selection is just built right into the model's training process itself. It's a really nice balance of performance and efficiency.
Now, those three strategies, filter, wrapper, and embedded, that's the classic toolkit. But the research we're diving into today makes a really interesting point. The very nature of data is changing, and that means we have to start thinking differently.
Right? What happens when your features aren't just sitting there nicely in a static spreadsheet? What if new data is pouring in every single second? Or what if your features are all connected to each other in these complex webs and groups?
Well, it means that those classic one-size-fits-all approaches just aren't going to cut it anymore. The game has changed. The unique, complex characteristics of modern big data demand a whole new generation of feature selection techniques.
And these are really the big three challenges right now. You've got streaming data, like a social media feed, where new topics and features can pop up at any second. Your selection has to be dynamic. Then there's structured features, like genes in a biological pathway. You might not want to select individual genes, but the whole group together. And finally, heterogeneous data, where you're trying to pull insights from totally different sources, like text, images, and network data, all at once.
So let's bring this all home. We've talked about the problem, the classic solutions, and these new emerging challenges. So why does any of this really matter to you? Why is this so fundamental?
Because it is the unsung hero of this whole field. Seriously. We all get excited about the super complex algorithms and these massive neural networks, but so often the real magic, the thing that makes it all work, happens before the model even gets trained. It's in the careful, intelligent preparation of the data.
So, if you're going to remember a few things, make it these. First, that cursive dimensionality is very real. More data is definitely not always better. Second, feature selection is just the art of finding that signal in all the noise. Third, this is the step that makes our models fast, trustworthy, and understandable. And finally, as we've seen, there's no single best way to do it. The right approach always depends on your specific data.
So I'll leave you with this final thought to chew on. The next time you see an AI do something absolutely amazing, ask yourself, was the magic really in the fancy algorithm, or was it in the incredibly well-chosen features it was given to learn from? Thanks for tuning in.